Now, let's go to the law of ideal gas. As we can see that the law of ideal gas, yeah, the law of ideal gas, Dalton expression about the gas, ideal gas, sum of partial pressure of gas is equal with the total pressure of gas, which show here, if I have the gas, two, here I have oxygen, yeah, and I have nitrogen, argon, water, and carbon dioxide. Each of these gas, pure gas, show the partial pressure, which if we total this partial pressure, it will same with the total pressure of air. That is an that is a statement of Dalton law of ideal gas. Ideal gas law of Avogadro also state the ideal gas in the mole substances component perception. Here you can see I have helium gas and ammonia gas, also oxygen gas. Each are show you 1 liter. Total amount gas, which is we can make fixed pressure and temperature equal with the volume. You can see here that if we fix the pressure and temperature, the total amount of the substances, it will equal with the volume. Boyle ideal gas. In this Glenn Research Center, it shows you that for a given mass, at constant temperature, the pressure time, the volume is constant. Here I have two picture. Okay, I have two picture, which is the first picture you can see here. I burn, increase the temperature by give it boiler. In the 17th century, Robert Boyle studied the behavior of gases systematically and quantitatively. In one series of studies, Boyle investigated the pressure-volume relationship of a gas sample. The demonstration of Boyle's law, here you can see in the first picture that the pressure is 1 atmosphere and the temperature is 300 when the given mass fixed make it constant mass, it will be it will give the different volume if we increase the pressure. That is a linear in correlation between volume and pressure, but it's not actually, it's given a curve like this. Next is the Charles and Guy Lussac law of gas. Charles and Guy Lussac law make a simple experiment to show the relation between volume and the temperature. Here you can see that when in the first picture we increase the temperature with the burning system, the volume is increased. But when the temperature low and we off the fire, the volume will decrease. It show you that volume will equal with the constanta times the temperature. Charles show the correlation between temperature and volume in this curve, in this diagram. The last is Guy Lussac, which show you that the equation of gas, pressure, and temperature at fixed volume will give the constant number. And it show you the formula here that pressure 1 over temperature 1 is equal with pressure 2 over temperature 2. So by the correlation, when temperature increase, the pressure will be increased also. And the opposite, when the temperature decrease and pressure will be also decreased. We can make all the ideal gas that been explained in one formula, which here pressure and volume, product of pressure and volume will give the constant it's stated by Boyle. Okay, we can combine the ideal gas law and that we have been discussed into one formula. Here we show that the first gas ideal comes from Boyle when he and when volume decrease, the pressure increase, and while Charles expressed the correlation between volume and temperature, which the temperature increase will make volume increase, and Avogadro gives statement about relation between amount of substances and the volume. And here are the last Gay-Lussac. So we can see here that all component will be stated in the formula and give the Boltzmann constanta.
Okay, student, we have finished discuss the topic of basic law of chemistry. So see you next week in the next topic. Thank you. Assalamualaikum warahmatullahi wabarakatuh.